Welcome to Mathmerge. In this video, I will go through what is highest common factor, or in short, it is called HCF. It is also called as greatest common divisor or GCD. So highest common factor or GCD of two numbers. Also, what are the different methods to find HCF and its real life applications, and how to find HCF of three numbers. If I have two numbers, like say here I have 260 and 1430, their GCD or HCF is the highest number which divides both without without a remainder being left. So I mean that number I should be able to divide 260 and 1430 also, and there should be no remainder. So how to find out highest common factor or greatest common divisor of a pair of numbers? Let's first find highest common factor by prime factorization method. I have two composite numbers and I write down their prime factorizations vertically. Say I have 260 and 1430. So I write down their prime factorizations vertically. The least prime number which divides 260 without a remainder being left out is 2. And 2 times 130 equals 260. So I write 130 here. Again 2 divides 130 and 2 times 65 equals 130. So I write 65 over here. And then 5 is the least prime number which divides 65 without a remainder, and 5 times 13 equals 65. So I write 13 over here, and then 13 times 1 equals 13. So 260 equals 2 times 2, like 4 factors are there, 2, 2, 5 and 13. We multiply them. And 1430, the least prime number that divides it is 2, and 715 times 2 equals 1430. So I write 715 here. Then the next prime number is 5. 715 divided by 5 equals 1 goes in 7, 5 goes once in 7, 2 is carried over. 5 goes, I have a new number that is 21. 5 goes 4 times in 21, 1 is carried over. And 5 goes 3 times in 15. So I have 143. So 143 times 5 is 715. So the next number I write is 143. Then I have 13 as the prime factor. 13 goes 11 times in 143. And then the last prime factor is 11. 11 times 1 equals 11. So 1430 equals 2 times 5 times 13 times 11. So what is the common factor in this? I can say that 2 here, 2, 5 and 13 are the common factors in these two numbers. So what is the HCF? HCF is a product of these common factors. 2 into 5 into 13 equals 130. So 130 is the highest common factor. I can also find HCF by Euclid's division lemma or Euclid's division algorithm, which was devised by a Greek mathematician, Euclid. In this method, I have to divide the greater number, which is 1430, by the smaller number, which is 260. So the smaller number becomes the divisor and the greater number becomes the dividend. And I can try 260 times 4 equals 4 times 0 equals 0. 4 times 6 equals 24. 4 times 2 equals 8. 8 plus 2 equals 10. So 260 times 4 equals 1040. I can still add 260 to 1040, and the answer is 4 plus 6 10. 1 is carried over, 1 plus 2 3, and 1. So 1300 is less than 1460. So I can say this is 260 times 4, and this is 260 times 5. So I can say 260 goes 5 times into 1430. So the quotient is 5, and I subtract 1300. The answer is 130. So this remainder becomes in the next step, the step after this, this remainder becomes the new divisor, and the divisor in the previous step becomes the dividend. So I have 260 divided by 130, and 130 goes twice in 260. I multiply 2 with 130, subtract 260, the product from this dividend. The remainder is 0. So the HCF is the divisor in that step where the remainder is 0. Here the remainder is 0, so this is the HCF of the two numbers. I can also find out the HCF of these two numbers, 260 and 1430, by the common division method. So that is just another way of finding. We have already learned two ways. First way is listing down the prime factorizations vertically. The second way is Euclid's division lemma. And then again back to common division method. And how do I find out the HCF using the common division method? I write down both the numbers together. That is 260 and 1430. I write down them like this, and the prime factor, which is the least and divides both of them without any remainder being left out, is the prime number 2. And I've already seen 260 divided by 2 equals 130. So below 260 I write 130. That is 2 times 130 equals 260. And also from here 2 times 715 equals 1430. So the next number here is 715. Then again choose a prime number which divides both without a remainder, and it is not 2 this time, because 715 cannot be divided by 2, but 130 can, but we cannot choose 2 since it doesn't divide both the numbers. So the next prime number is 5. It divides 130 without a remainder and 715 without a remainder. So 26 times 5 equals 130. Let me try out. 26 into 5. 5 times 6 equals 30, and this. So 130. So this is 5 times 26 equals 130. And from here I can find out 715 divided by 5 equals 143. So the next number I write down below 715 is 143. Then these two numbers can be divided by 13. It is a prime number, and when I divide these two numbers by 13, it doesn't leave any remainder. As seen from here, 143 is divisible by 13. The answer is 11. So here I write down 11, and this I write down 13. 2 times 13 equals 26. And there is no other prime factor which can go beyond this step. 2 is also a prime number, 11 is also a prime number. There is no other number which can divide these two. So this is the final step. I cannot go beyond this. And the HCF is the product of these three numbers on the left. So the HCF equals 2 times 5 times 13 equals 130. So I can see by the three methods I find out the same answer, which is 130. Next I go for the sums on the real life applications of HCF. So say first is I have a cuboid of length 120 centimeters, breadth is 60 centimeter, and the height is 30 centimeter. I have to measure the dimensions of this cuboid with a common rod and exactly. What should be the length of the rod? So basically I am having a certain cuboid. Length is equal to 120 centimeter, and then breadth is 60 centimeter, height is 30 centimeter. I need one rod which measures these three exactly. So basically without a remainder being left out. So obviously that is the HCF of these three numbers. So I find out the HCF using the prime factorization method. I list down the prime factorizations of these numbers vertically. And vertically I do it. First number that divides is 2. 120 is 2. So 2 times 60 equals 120. Then again 2 times 30 equals 60. 2 times 15 equals 30. Then 3 times 5 equals 15. Then 5 times 1 equals 5. Then I do for 60. 2 times 30 equals 60. 2 times 15 equals 30. 3 times 5 equals 15. Then 5 times 1 equals 5. Then for 30, I basically have to do this part only. So 2 times 15 equals 30. 3 times 5 and 5 times 1 equals 5. So basically 120 equals 2 times 2 times 2 times 3 times 5. And 60, I have 2 less. So 2 times 2 times 3 times 5. And 30 equals 2 times 3 times 5. So I can see these are the common factors. So the HCF, this 2 times 3 times 5 is there in all the three. So HCF equals the product of these three numbers, which is equal to 30. So if I have a rod of length 30 centimeter, that is the answer. A rod of length 30 centimeter, I will be able to measure the length, breadth and height exactly. I need just one single rod of 30 centimeters. Then the next sum is, next real life sum is, find the largest number which when divides 195 and 363 leaves remainder 3 in each case. So basically I'm dividing two numbers and it is not these two numbers but remainder 3 is left out. So basically these numbers, I subtract 3 from these numbers which equals 192 and 360. I am actually dividing these two numbers and it should be a single number and 3 should be left out as a remainder. So when I add 3 I get these two numbers, right? So basically I have to find the HCF of these two numbers. Let me do it using the common division method. 192 and 360 I write down together. The least prime number that divides both is 2. So 2 times 96 equals 192. 2 times 180 equals 360. Again I have 2. 2 times 48 equals 96. 2 times 90 equals 180. Again I have 2. The next two numbers are 24 and 45. Then I cannot have 2 because 45 is not divisible by 2. So I'll have the number 3. So 3 times 8 equals 24 and 3 times 15 equals 45. So I have 8 and 15. But 8 and 15, there's no common prime number that divides 8 and 15 both. So I cannot move beyond this step. So the HCF is the product of these numbers on the left, and the answer is the product of these four numbers, which is 8 times 3, which is equal to 8. I mean, that is 2 times 2 times 2 times 3, that is equal to 24. So I can see 192, it is divisible by 24, and the answer will be equal to 8, I guess. No, the answer will be equal to 24, 12 times 2, 12 times 1, and this is 7, 12 times 6. So the answer is 8. And 360 is divisible by 24. The answer is 15. Yes. So 100, I add 3 to 192, I get 195. And I add 3 to 360, answer is 363, and this is 195. So when I divide these two numbers by a single number, which is 24, and remainder 3 is left out. So basically that number is 24. So the next sum I do is again find HCF of two numbers, which is 182 and 273. So I will do it by listing down the prime factorizations vertically. So the first number that divides, the first prime number that divides 182 without a remainder being left out is the number 2. So 2 times, like I do 182 divided by 2. So 91 times 2, like 2 goes into 18 9 times, and 1 into 2, once into 2. So 2 times 91. Then I can see, does 3 divide 91? What is the sum of the numbers? 9 plus 1 equals 10. This sum is not divisible by 3. So this 91 is not divisible by 3. Is it divisible by 4? So for 4, the number in the tens and the units place should be divisible by 4. Here it is not divisible because it's an odd number in the units place. And is it divisible by 5? No 0 or 5 in the units place. So not divisible by 5. It is not divisible by 3 and 2, and so it is not divisible by 6. Is it divisible by 7? I do 91 over 7, and 7 goes once in 9. Remainder 2 is left out, which I carry over to 1, and 7 goes 3 times in 21. So the answer is 13. So I have this prime number 7, which divides 91. Answer is 13. And then next, 13 times 1 equals 13. Then I have the number 273. Which number divides 273 and it's a prime number and no remainder is left out? I guess it is 3, because 2 plus 7 plus 3 equals 12, and 12 is the sum of these numbers. It is divisible by 3, and since 3 is at the units place, not an even number, so it is not divisible by 2. So the first number is 3, and 3 goes 9 times in 27 and once in 3. So the answer is 91. And again for 91 I have 7 times 13 and then 13 times 1. So 182 equals 2 times 7 times 13, and 270 equals 3 times 7 times 13. So what are the common prime factors? 2, no sorry, not 2. I have 7 and 13 here and 7 and 13 here. So HCF, or the highest common factor, is the product of 7 and 13, which is equal to 91. And then I have again another sum, find HCF of three numbers. Here I have three numbers, not two numbers, right? And I first find out the HCF of these three numbers with the common division method, and then I do it with the prime factorization method by listing down the prime factorizations vertically. So I have 36, 72, and 288 written all together in one line, and the least prime number that divides all the three without a remainder being left out is the prime number 2. So since 6 is at the units place, it divides 36 to 72. 2 is at the units place, so 2 divides 72, and this is also having an even number at the units place. So again 2 divides 288. 2 times 18 equals 36. 2 times 36 equals 72, and 2 times 144 equals 288. Again, these three numbers have an even number at the units place. So the next prime number which divides these three numbers is again 2. 2 times 9, 2 times 18, and 2 times 72 equals 144. Then I have these three numbers, 9 comes, so 9 is not divisible by 2, but these three numbers are divisible by 3. 9 is also divisible by 3, 18 also, and 72 also. The sum of numbers 7 plus 2 equals 9, so it is divisible by 3. That sum 9 is divisible by 3, so 72 is divisible by 3. What are the quotients when I divide these three numbers by 3? 3 times 3 equals 9. 3 times 6 equals 13, and 3 times 24 equals 72. Again, I have these three numbers, and again 3 will divide these three numbers. So what is the quotient? 1, 2, and 8. Beyond this, I cannot move forward because there is no prime number which divides these three together. So the HCF is a product of these four numbers on the left. So the HCF equals 2 times 2 times 3 times 3 equals 4 times 9 equals 36. The HCF is equal to 36. And now I do it by listing down the prime factorizations vertically. 36, 2 is the prime number which divides, quotient is 18. 2 times 9 equals 18. Then 3 prime number, 3 times 3, and 3 times 1 equals 3. That is the end. Then I have the number 72. 2 times 36 equals 72. 2 times 18 equals 36. 2 times 9 equals 18. Then I have the prime number 3. 3 times 3 equals 9, and 3 times 1 equals 3. Then I have the number 288. 2 times 144 equals 288. 2 times 72 equals 144. 2 times 36 equals 72. 2 times 18 equals 36. 2 times 9 equals 18. 3 times 3 equals 9. And 3 times 1 equals 3. So HCF is a number that occur in all the three prime factorizations, which is here 2 twice and 3 twice, here 2 twice and 3 twice, here 2 twice and 3 twice. Again, I get the same answer for the HCF, which I got here, which is 2 times 2 times 3 times 3, which equals 36. Thanks for watching. If you like my videos, please like, comment, share, and subscribe to my channel. Thanks a lot.